Okay, so please, what do we get here?
Log 3.
What do we get here?
Log 3.
Log 3. So you change this to 9, correct?
Yes.
So you did 2 times 9 divided by 6. Okay. Please, I need us to be serious now. What about this? Log base A,
P over Q squared.
P over Q squared.
Times R.
Can you put that in a better form? Root R. You didn't say it, but when I see the way you were. So you were supposed to get log base A, P root R over Q squared. That's what you should get. Okay, if you write R to the power half is fine, but write it better. Okay, what about this? Can you stop the noise?
Log base B.
Log base B,
B squared.
AB squared, because this can be changed to BB, right?
Yeah.
Because anything, so then you can have the same base. Alright, what about this one? Log base A. This will be R1 to the power 4, right? Then you have to multiply by, plus first, mn squared, 3 to the power 4. So everything will be log base A, m1 over 4 times m3 over 4 times n3 over 2. Yes?
Yeah.
So this should be just m. So you have log base A, m, n3 raised to power 3 over 2. Correct? Okay, great. What's going on? You just look at what you get. Stop. I don't know what this discussion is about, but I'm not finding it funny anymore.
No, I get that question. I got it wrong.
Okay. Okay, what about this without the use of calculator? So the first thing you change this to what?
Log base 2.
Log base 2, what must be the number?
8.
That's 8. So the best way to look at it, and the easiest way, is to assume there's a log 2 base 2 here. Okay? Such that this has to go this way. Then you can have log base 2, 12, divided by 48. Oh, divided again?
Divide by.
Then that would be times at the bottom. 8, like that. Is this?
Yes.
Yeah, because you have to divide. So if you want to 12 divided by 48 divided by 8.
Yes.
And that's times 1 over 8. Okay? So 12 times 12 divided by 48 times 8. So what do you get eventually? Log base 2, what's that? What's the number?
2 to the power of negative
1 over what? First? 32. So if you simplify that, you get negative 5. Negative, no. 1 over. Is it negative 5? Yes. Okay, so next one.
Mr. Daniel,
Yes, sir.
for that question, I didn't do the part on the 3. I just did the first 2, and then I just subtracted 3 from the end. Won't that be easier?
You did what?
So like, instead of
Oh, you simplified the first 2,
Yeah.
you subtracted 5.
Yeah.
Okay, that should work. Do you understand what he just said?
No.
So he just simplified this. He simplified this, and he probably got minus 2
Yeah.
while keeping the minus 3. Yes, you can do that. Okay. So now, this we have all done. Also change of base. I'm just repeating it because of those that are not here. So this is log to base 4, log to base 3, log 8, log 4. Okay? This cancels this cancels that, and that is log 8 over log 2, and that will be log 2 cubed over log 2, and finally you get 3. And you do the same here. So like I said, this means product. Sigma means sum, and this means product. So you are going to multiply. When k is equal to 2, that will be 3. When k is equal to 3, this will be 4. When k is equal to 4, the number will be 5, and you continue. When k is 1023, you have 1023 of 1024. So you change the base again, just like this, and you'll be left with log 1024 divided by log 2. Okay, this we have talked about. I believe everybody gets what is on the board. And this, you can have it in two ways. You may have log b plus log a to the power 4 equals 1. You can do that, right? When this moves here, it becomes positive, right? And of course, the power becomes the power of a. The coefficient becomes the power of a. So such that log a to the power 4b equals 1. Product, right? Then from here, this is base 10. So that will be a to the power 4b equals 10. Is that what you got? So alternatively, I could change it to log b equals log 10 a to the power 4. Because log 1 is going to be log 10, and I can have here log a to the power 4. I can do that as well. Okay? So with this, I get log b equals log 10 divided by a to the power 4. And because I have logarithm of the same base on both sides, I can equate the numbers. b equals 10 divided by a to the power 4, which is the same as this. And this is simply subtraction, right? For you to have that, it has to be subtraction. So that will be log m to base a minus log n squared to base a. But this is not the final. Who can tell me why? In terms of log m and log n, it never said square. So you just make sure the power is dealt with. Although I think this is also right, but you know, let's just write it like this. It's like the reverse of the first question, kind of. Okay, so similarly, this will have to be distributed, right? Then we do subtraction again. So when we distribute and subtract, you get square root of m now to power 2/3 minus log to base a, the cube of n to power 2/3, something like that. Yes? So this will be half times that, and that will be 1/3. This is what I mean. Log to base a, m to power half, then to power 2/3. And this is a n squared. Correct? Questions? Question? What? Then we'll bring back to yes. So this multiplies this, you have 1/3. So that will be 1/3 log to base a m, then 2 log to base a n. Okay? So these are new. These are based on what we have learned and what we know, right? So this may be new to some of us, but it's not entirely new. Now, I'm expecting Mr. Praveen. If you see him, please let me know. So this is like, I just call it reciprocal of logarithms. So reciprocal means 1 over something. So reciprocal of 2 is 1/2. Reciprocal of 4 is 1/4. Okay? The reciprocal of 2/3 is just 2, 2/3 will be 3/2. So it's like you flip it. Okay? So if you flip 5/1, which is just 5, the reciprocal will be 1/5. The reciprocal of a number is the multiplicative inverse of the number. I mean integers now, and maybe rational numbers. Because when you multiply both of them, you get 1. So you multiply a number and its reciprocal, you always get 1. And that one is called the multiplicative identity. I'll be talking about identity and all this stuff, you know, as time goes on. So basically, if you want to get the reciprocal of a log, it's the same as just flipping the position. That's it. X was the base, n was the real or the original number. So when it is reciprocal, they swap cases. That's the easiest way to know it. So my first task here is to show this. How do you think we can show this? Change the base. Initially, you have log base x, right? you must prove the law, you have to change the base to what?
Y.
Base y. So how do we change base? The first log base y, right? Then log base y. Then I ask you to write this exactly the way it is. So you have y, you have x. What do you see? 1 at the top. And this is law or property. Okay?
What if there's a power on log y to the base of x?
Like this.
Yeah, what if
Take it to the back. This will change, then the number stays. So if I have 2x, it's just 2 times x. I don't care what happens to x. Change x to whatever you want to change it to. Okay, I'll show you one thing. So I have here 2x, which is 2 times x. Then you told me your x is actually 3/4 in disguise. So then you write it as 2 times 3 divided by 4, right? Or you decide to say, oh, because you just learned indices in school, 4 divided by 3 to the power minus 1. That's your business. You do whatever you want, as long as 2 maintain its position.
Yeah, Mr. Daniel, I think I think I'm missing something. How can you swap, like, how can you go from log base x, like, of
You mean
log-
here?
Yeah, yeah.
Okay, remember change of base from last lesson.
Log 7.
What? Which
Yeah, I don't know the number, but maybe it's log 7. So there's something we learned last time, that if you have log a base b, you can change it to base x and write like this. So I told you the first thing is, write it as a fraction in the new base. Okay? And I said the second thing is, write this exactly the way they are. A is at the top, B at the bottom. Remember this? Do you remember this? Sort of. Okay, check your notes. It's from last class. Okay? So that's what we use here. I just check the note later because of the time. But it's a property we have done before. Okay, it's a property we have done before. Can you confirm which law it is?
7.
Is it 7? So just check law 7 from last lesson.
Okay.
And that's exactly what we use here. Do you remember this? Did you do this question?
Yeah.
Exactly, that's what we are using. The only thing here is we have changed this to base what? Everybody?
10.
Base 10. That's the same thing we have done. Okay? So that's how you simplify this. So what will be the first part here? Log what? I've written examples. So when you flip, you just change the positions. So if I want to flip this, because it looks like reciprocal, right? So what would this be? Log what? Log 3.
log 3 to base
Base 6. And this would be log 2 to base 6. What are you looking at?
multiplication.
Multiplication.
Yes.
And that gives you what? 1.
Yes.
Okay?
Damien, you're too tall.
Understand?
For once.
Okay, so also, here we can flip. But like this guy remains. Because when you have 1 divided by 2y, it's the same as half times 1 over y. Nobody cares what happens to this dude anymore. By log, you can do whatever you like with it. Just maintain your half. Okay? So, or you could take this back. But my fear is, if you take this and make it 25, by the time you flip it, that becomes base 25. And this will be base 5. It's pointless.
So
Let's leave it as half.
yeah.
Okay? So like this. So log base 5, 40. And this is 1 over 2. Like that. Do you agree this is the same as this?
Yes.
So this is what gets affected by the law. And that becomes what? This will be 1 over 2. Log what? No. Log what?
64.
64
Base 5.
base 5. And this remains log 40 base 5. Now this can be evaluated because half of course can do something with that 64. Yes? So what is the final result? That's only 1 again.
Yeah.
That's weird.
Wait, that's 1?
Yeah. 1 is so stubborn, it keeps coming up, right?
Wait, so it's 8, right?
Yeah. So when you
Okay.
do division,
And then if you do, oh, it's 1.
alright everyone? So we have about 5 minutes to leave. Let's focus on the last dude right here. We will use these skills in solving equations when we come tomorrow. Okay? I will try as much as possible not to break down so I can be here. And I have just you guys tomorrow anyway, so it shouldn't be that stressful. I'm actually bored. But I won't be bored, trust me. I have Eminem I can listen to. And some Nigerian songs. Anyways, let's look at this. Guys, please, let's look at this. When this law is about an integer having an index number, or let me say an exponential function, put it that way, where the power is a logarithmic function. The power contains log. Okay, so the law tells us that if the base of the log at the power is the same as the base of the exponential itself, then you can actually cancel everything and maintain just this alone. So what that means is this: if I have 3 raised to power and this base is 3, whatever function of x is what remains. Okay? So if I have it as 7 and this is log to base 7 and this is maybe sine x, the result is just sine x. That's the question I'm asking here. And that's a very good question. Why? Can anybody think of how we can approach this? If you want to establish that, yes, this is actually true. We are going to learn proofs, okay? But can you think of something first? Yes, sir.
Is it because if you bring the a to the other side, it'll be log x base a equals log x base a?
Let's write that. Log like this or the other way. Log x base a like this?
Yeah.
Equals what?
Equals log x base a. Right?
It's right, but that's not the way we look at it. But it's right. Because if you are able to establish that left, Brandon, do you understand how this?
No.
Does anybody understand it?
No, because...
Okay. No, wait. I need them to remind them of that law. What is that law?
1.
Yeah.
No, not 1. There's a law that talks about how you can change logarithmic expression to exponential form.
Oh, 6.
6. Everybody go to law 6.
Yeah.
Are you in law 6? Okay, so in your law 6, can you tell me how I wrote it in your note?
Log base a x.
No, what is there? Okay, log base
x base
a x equals what?
Y.
Y. Then I said this means x equals a to power y, right? Now in this case, your x is your a.
Oh my god.
Your x is your
X is your X.
Okay, your x is your x. Now your y is log ax. Agree? So now, let's now write this form, putting our y as this. What do you get? Whoa! That's what it's saying. And that's perfect. Move, I'm moving.
Okay.
Wait, Brandy, you still don't get it?
No, I get it. I just need to understand it.
It is time to digest what he has just eaten into his brain.
I realize my friend.
Okay.
Okay? Yes?
No, I get the whole.
Okay, wait.
Okay.
That y is now log ax. So this step is this step. A to power y equals x. And this is the same as log ax equals y. You agree?
Oh.
Ah. Okay, but this just tells you, what he has said just tells you there's no contradiction. Contradiction will have existed if eventually we got log x base a equals maybe log a base x. No, we are not sure this is true. Then we can say his conclusion is not right. So because we do not have a contradiction, his conclusion is actually right. However, what if we want to justify that this is actually true? Why don't we pretend we don't know what this is? Okay, let's pretend we don't know what that is. Let's a to power log ax, let's introduce a new variable. Okay, let's say r. Okay, I don't want to use something too common, so we don't mix it up. Let's say whatever we get is r. If r becomes x eventually, then we have justified the result. Okay, so from here we can go back to our law 6, which says if you have this, then you can have this. Then we can say, oh, that means if we have this, then we can have this too. So this is exactly what we have here, where this is our y. Okay, so I would say compare to log, no, not log, a to power y equals x implies what? Log, remember the base is still the base of the logarithm too in that form. That would be log base a, are you with me?
Yeah.
Of the number x is equal to y. I'm just copying back the law 6. Because this is what I said we take the power on the other side and become this.
Yeah.
So this is actually a biconditional statement. So if this happens, this will happen. If this happens, this will happen. If and only if. Okay, we'll get to all those jargons later. Alright, if you compare to this, what do you notice? This is your y, isn't it?
Yes.
So if I write, since this can give me this, then I can write this question, then a to power log ax equals r becomes what? Log to base a of x. Where is our x? That is whatever you have on the other side, which is r, is equal to what? Is equal to y. What is my y this time? The power. What's my y here? Log ax. Do you agree?
Yeah.
I should color code this stuff. Power y log x base a. Can you see that? And this is the same y. Okay? So, from here, my power log x base a. And where does the power go? It goes to the other side. It comes here. Okay? Can you see that?
Yes.
So, we have solved equation today. We established that if the logarithm of two different numbers are equal, then the two numbers must be the same, right? So, if the logarithm to the same base are equal, what does that tell us? It shows that r is equal to x. Remember, you assume that everything is r, and now you establish that r is actually x, and that justifies it.
Oh.
Nice.
Okay? So what he has done is to test if it is wrong, because I've proved by contradiction. We'll look at that. If he has gotten a wrong thing, it will have said no, then it's not the case. Okay? But this is a better way to look at it.
Someone's outside.
That must be Mr. Praveen,
I don't think
or the other coding guys.
No, it's a student.
Alright, who's that? Come in, come in.
It's the program thing.
Any questions? No? Albina, come on in. Bring your bag in.
Why don't you just leave the door open?
Okay? Oh. Just sit anywhere. They don't bite, at least for now.
No, we fight.
Continue.
Okay? Any questions?
No?
Alright, so we will apply this principle in various questions tomorrow as well as. So now we are done with every property of logarithm that needs to be learned. Okay?
Yes.
Okay.
So with this, we say bye-bye to
Bye-bye.
ourselves.
I really gotta go.
Do I stop? No?
Yes, sir.
Okay.
Just press the red button.
Never mind. I just
Oh,
want
you
to
just
ask.
download
You will
for
send.
that.
No, absent.
You will send.
Damon, do you want to say thanks
Yeah.
for watching?
So Daniel, I could join on
No.
the YouTube.
They're gonna look fun up.
Yeah.
You what?
I could join on the YouTube.
Alright, go for 5 minutes. But